In this video, we will explain the causes of a common and potentially damaging condition in fluid transfer: cavitation, what causes it, and how to manage it. Cavitation is caused when small gas bubbles entrained in fluid collapse and implode inside the pump. Not only is this condition common, but it is highly destructive to pump components. Evidence of cavitation: excessive noise and vibration. The gas bubble implosions sound like gravel in your pump and can cause potentially damaging vibrations. Cavitation is most common in applications with low net positive suction head, or NPSH, and when transferring materials with high vapor pressure, such as LPG, NH3, refrigerants, condensates, acetone, gasoline, or highly viscous fluids. Vapor forms when liquid pressure drops below vapor pressure. There are many potential causes: excessive lift, long suction piping, flow restrictions near the inlet, such as a pipe elbow, a clogged strainer, or when a valve is constricting flow, or where there is excessive flow velocity, which can be caused by undersized piping. These elements combine to reduce the system's NPSH available. And the damage to pumps? Mechanical seal failure, bushing failure, vibration, pitting, or broken vanes. This test lab will allow us to measure conditions and performance and show us how to mitigate cavitation destruction. The test stand has clear inlet pipe runs leading to the pump. All conditions are being carefully controlled and monitored so that we can fairly evaluate multiple pumps under identical settings. Finally, these gauges and valves control the operating conditions, and we can see the inlet and discharge pressure on this monitor. We will be testing pumps with and without this unique device, specific to Blackmer sliding vane pumps. It is a cavitation suppression liner and is designed to mitigate the negative effects of cavitation. We'll come back to this in a moment. First, let's run this Blackmer LGL3 sliding vane pump without a cavitation suppression liner. Note, these are cavitation gas bubbles illuminated by a strobe light. Here's what cavitation sounds like without the suppression liner. Now let's perform the same test on a Blackmer pump equipped with a cavitation suppression liner. This unique yet simple device, designed by Blackmer's engineering team, is highly effective in managing cavitation inside the pump. Blackmer's cavitation suppression liner reduces energy released by gas bubbles, thus reducing cavitation damage. In a moment, you'll see that the liner is reducing the effect of cavitation. This is done by allowing a controlled amount of fluid at discharge pressure to bleed back toward the suction of the pump, and this breaks apart large vapor bubbles before they implode, forming many smaller vapor bubbles, and the net result is less noise, less vibration, and less wear. Now, let's see it in action and measure the results. The cavitation suppression liner makes the pump perform smoother and quieter under identical conditions. Here we see the difference side by side. The pump on the left has no liner, while the pump on the right is equipped with a cavitation suppression liner. To summarize our findings, the unique characteristics of the Blackmer cavitation suppression liner can greatly reduce the damaging effects of cavitation by managing the entrained gas bubbles inside the pump. As seen on this graph, the positive results can lead to a measurable reduction in vibration, noise levels, and ultimately reduced wear and tear on internal pump components. This technology is especially beneficial when NPSH required is greater than NPSH available. The cavitation suppression liner is available on a wide variety of pump models for both stationary and transport applications. In fact, Blackmer is recognized as the global leader for liquid transport transfer applications. For more information, contact Blackmer or visit your authorized Blackmer dealer.
PSG, where innovation flows.